Thank you for sending this question. This is a good example to look at because it reminds us this important application of derivatives, that the derivative at a, so at, in this case, x equals 4, that derivative is going to give us the slope of the tangent line at a equals 4. So let's look at this problem. I've worked it partly out so that this video, you could pause it, but it'll make the video go a little bit more quickly. But feel free to pause as much as you need to if you want to follow along a little more slowly, because I'm going to, if you want to stop to write any of this down. But f of a plus h would be the square root of 4a plus h, because we're going to replace the x with a plus h, plus 65. Now, when we're given this point, 4, 9, that means that a, in this example, a is 4, right? We're looking for the derivative or the tangent when a is 4. So I'm going to replace the a with 4, and when I do that, when I replace a with 4, I get that f of 4 plus h is the square root of 81 plus 4h. Then when I do f of a, that's going to be f of 4. I get the straight square root of 81, which is 9. Let's move on to a new page so we have space to do that. So here we've got our f of a is 9, f of 4 plus h is the square root of 81 plus 4h. When I fill that in to our formula for the slope of a tangent, which is this formula for the first derivative, I get the square root of 81 plus 4h minus 9 over h. I am going to try direct substitution, but when I let h equal 0, I get 0 over 0, which is undefined. So I don't have to think of another tool to simplify this with, so that I can eliminate having this h by itself in the denominator. Want to find a way to divide out this h in the denominator, and hopefully you're already thinking, oh, I know how to do that. I'm going to multiply by the conjugate. So since this is subtract 9, I'll do the square root plus 9, and then to keep it equivalent, to make it a 1, I'll multiply the denominator also. And then I'll take the limit. And if we do this correctly, if we work it all out correctly, we should see that h in the denominator, this h dividing out. Let's see. I'm going to use the fact that a plus b times a minus b is a squared minus b squared to speed up this multiplication. So I've got the square root of 81 plus 4h times the square root of 81 plus 4h. Or in other words, the square root of 81 plus 4h squared. And when I square a square root, I undo the square root. So I've got this 81 plus 4h minus 9 squared, so minus 81. And then in the denominator, I'm not going to multiply this out. I'm going to leave it in this factored form, because remember, my goal is to try to eliminate that h. And sure enough, look what happens. 81 minus 81 is 0. So I'm left with the limit of 4h over h times the square root of 81 plus 4h plus 9. Always be mindful that you're remembering that we're doing the limit, right? So carry that limit as h approaches 0 all the way down. Here's our 1, our h over h divides out, and now I'm ready to go with direct substitution. So I'd get 4 in the numerator, and the square root of 81 plus 0 plus 9, or in other words, 4 over 9 plus 9, 4 over 18. But wait, there's more. We need to reduce it. We can reduce this by 2. So 2 goes into 4 twice. 2 goes into 18 9 times, and there you go. You've got the 2 over 9. Now, the second part says to determine the equation. I'm going to leave that part to you. I will say that I prefer the y equals mx plus b formula because I don't like memorizing that y minus y1 equals m times x minus x1. Well, of course, I've already got it memorized, but I don't like having to recall that. And I find some students find it easier to just use this y equals mx plus b. So we replace y with 9. We replace m with 2 over 9. We replace x with 4. And then that'll leave us with just a linear equation to find b. And then to write the final answer as y equals m, we already know is the 2 over 9, x plus whatever we get for b. I hope that this video helped. Thanks again for sending the question, and let me know if you need further assistance.